Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam FM and financial mathematics. You are given the following information about an n-year bond where n is more than 10. The bond pays 8% semi-annual coupons and has face amount of 1,000. Now notice that this means that really the bond pays a 4% coupon every half a year, so every coupon is 40. The bond is redeemable at par, so at 1,000. The bond is callable at par 5 years after issue or 10 years after issue. P is the price to guarantee a yield of 6.8% convertible semi-annually, and Q is the price to guarantee a yield of 8.8% convertible semi-annually. And 6.8% per year convertible semi-annually means 3.4% per half a year. And 8.8% convertible semi-annually means 4.4% per half a year. The absolute value of P minus Q is equal to 123.36. Calculate N. And here is the solution. The yield of 6.8% convertible semi-annually is less than 8% convertible semi-annually, and therefore at the yield of 6.8% convertible semi-annually, the bond is selling at a premium. In such a situation, the earlier the bond is called, the more disadvantageous this is to the bond owner. Thus, the price to guarantee a yield of 6.8% is the price corresponding to the earliest possible call, so 5 years after issue. And that price equals, note that 6.8 convertible semi-annually means 3.4% effective per half a year. That's equal to P equals 4A angle 10 at 3.4%. So 5 years of coupons every half a year at 3.4%, plus 1,000 times 1.034 to the negative 10, because that's 3.4% per half a year over 5 years, which is 10 half years. That's approximately equal to 1,050.15. At the yield of 8.8% convertible semi-annually, the bond is priced at a discount, and therefore Q is less than 1,000 less than P. We already established that P is more than 1,000, but Q being less than 1,000 is an illustration of the bond being priced at a discount. That means that the price is less than the par value of 1,000. This implies that Q is equal to 1050.15 minus 123.96 because we are told that the absolute value of the difference between P and Q is 123.96, and that absolute value of the difference between P and Q is actually just P minus Q because P is bigger. And therefore Q is equal to P minus that 123.96, which is 1050.15 minus 123.96. And that's equal to 926.79. And because the bond is priced at a discount, the latest possible call is most disadvantageous to the bond owner, so we need to price the bond as called at maturity, or just redeemed at maturity. Therefore, Q is equal to 926.79, but it's also equal to 40 A angle 2n at 4.4% plus 1,000 times 1.044 to the power negative 2, which is 40 times 1 minus 1.044 to the negative 2n over 0.044, and plus 1,000 times 1.044 to the power negative 2n. Then we can write this as 40 over 0.044 plus 1.044 to minus 2n times 1000 minus 40 over 0.044. That's approximately 909.09 plus 90.91 times 1.044 to a negative 2n. Remember, we're trying to find n. This is an equation in which the only unknown is n. We need to solve it for n. And you should remember that whenever you're solving an equation in which the unknown is in the exponent, you will at some point need to take the natural logarithm of both sides of the equation. That's a standard procedure. Be familiar with it. So basically solve it for 1.044 to a negative 2n. Once you do this, take natural logarithm of both sides. That natural logarithm of 1.044 to a negative 2n becomes minus 2n times the natural logarithm of 1.044. So that when we solve it, n is equal to minus the natural logarithm of 926.79 minus 909.09 divided by 90.91 divided by 2 natural logarithms of 1.044. This n is almost exactly equal to 19, which is answer C. And that's we done with the problem. Please remember, this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.